All right. So I'm doing something with the recording starting today. Earlier my videos were like flipped. It will look like I'm writing in the opposite direction. So I have changed the alignment of the camera, hoping this time it gets better. So, all right. So what are we going to learn today? Did anybody get a chance to see the topic that I have posted in the WhatsApp group?
Sine, tan, and cosine.
Sine, cosine and tan periodicity, and then we'll talk about inverse trigonometric functions. These are the two topics that we're going to talk about. So, yeah, Ishwari.
I'm taking pre-calc right now, and we did inverse functions. And is it like inverse functions as in like logarithms and like exponentials?
No, inverse function is something like inverse of a regular sine, cosine or tan. So just to give us a very high level view of it, right? When you say, let's say sine 45 degree or sine of pi by 4, we know that this value is 1 by root 2, correct? We have derived it also, and we know it. Even if you don't remember, let's assume that this is what it is, okay? Now, when sine of 45 degree is, or sine of pi by 4 is 1 by root 2, the question can be framed differently, where they will say, find out if you have to find out what value of 1 by root 2, inverse of sine, which is called arc sine, 1 by 2, then you will say this is pi by 4. So it's like you are given a value of sine, which is called arc sine, and you have to derive the angle. Meaning, if sine of 45 is 1 by root 2, the inverse of function says, or you can also write this as sine of inverse of 1 by root 2 equals pi by 4. So basically, it's another way of looking at sine, cosine and tan in the inverse direction, meaning sine of something is some value. So what is inverse of this value in terms of degree or angle?
Okay, I understood.
Okay. So this is just a going in position. So let's start with this. Okay. So when you talk about let me recall the topic that I mentioned. Okay, so we'll talk about inverse of sine, cosine and tan, and then we'll also talk about periodicity. Now, what is periodicity? Let's look at the unit circle, and I think there's one thing that I forgot to mention in the previous classes. When we say unit circle, what we are saying is the radius of this circle is a unit. Okay, that's why this is called unit circle. So if you remember, when we looked at unit circle in a coordinate plane, if you pick up any point on the perimeter, what is the x and y coordinate? I said it is r, x coordinate is r of cos theta and y coordinate is r of sine theta. Remember? Here r is a unit, is actually a 1. So when you refer to a unit circle, you can assume that the x coordinate will be cos theta and y coordinate will be sine theta. Yep. So I was always referring to this, the radius of this as r. That is how the x coordinate was r of cos theta and y coordinate was r of sine theta. But when you are referring to a unit circle, the assumption is the radius is a unit, is 1 unit. So be it 1 centimeter, be it 1 meter, be it 1 kilometer, 1 foot, whatever it is 1. And that's why it is called unit circle. Okay, so that you don't end up grappling with r as a multiple to find out the coordinates. Does that make sense?
Yes, sir.
Arya, Dev, Rehan, everybody?
Yes, sir.
Okay.
Yes, sir.
Okay, so just one quick thing. I know that there was a student who wanted to join today and he has not joined. I think I missed to add that student in this group. Just give me 1 second. Just 1 second. All right. Yeah. So now let's go back a little bit to do a quick recap to understand what we know about unit circle. So as I said, if you're talking about a unit circle, you are talking about radius being 1 unit. So, and in that case, what we saw was, what is my x and y coordinate of any point? Obviously, the x coordinate will be the distance on this and on the x-axis, and my y coordinate will be distance on the y-axis. So, if you look at this as a theta, so this will be sine theta. We know that sine theta equals, let's say this is y. So y divided by the radius. Radius is 1 unit. So your y coordinate value is sine theta, and x coordinate value is this divided by, so sorry, sine cos theta equals the base divided by the hypotenuse. So base is your, let's say, x divided by hypotenuse is the radius, which is 1 here. So your x coordinate is cos theta and y coordinate is sine theta. Yeah. So that is how your x and y coordinate for this one is cos theta and sine theta respectively. So this part you guys recall and remember. Now, what do we mean by periodicity? What it means is how you are moving this by 90 degree. This angle, if this angle is theta, periodicity means what will be the corresponding changes when you move this angle by 90 degree. Or if you visualize this as a triangle AOB with the angle theta, if you turn this triangle by 90 degree, meaning if it was here, you flipped it and then it became, let's say, C and D. So this triangle moved by 90 degree and it became angle triangle COD. Okay, that means if this angle is theta, this angle is 90 degree. So this angle will be, so this angle from here to here will be 90 degree plus theta. Is this part, are you able to visualize what I'm trying to do? So I have an angle theta in the unit triangle, and from that we know that my x and y coordinates are cos theta and sin theta. What I'm doing is, I'm increasing this angle theta by 90 degree. So this line which was cutting here at point A moves by 90 degree and cuts at point C. So this angle from here to here is theta, which was the earlier angle, plus 90 degrees. Is that part clear?
Yes.
Arya, Dev, Rehan, are you guys able to relate to what I'm saying?
Yes.
Yeah.
Yes, sir.
So now, one thing that we have learned is any point on the perimeter, x and y coordinates will be equal to cos of the angle and sine of the angle. Okay. Here my angle have changed from theta to 90 degree plus theta, and this angle has changed from theta to 90 degree plus theta. Is that part clear so far? So basically same thing. We had an angle theta, we increased that angle by 90 degrees. So it became 90 degree plus theta or pi by 4 plus theta, whatever way you want to represent it. If you're talking radian, you are talking about the new angle. This line when moved to by 90 degree, this is my new angle. Here to here is pi by 4 plus theta or 90 degree plus theta, whatever you are comfortable with. Does that make sense?
Yes, sir.
Now, with the changed angle, what are my x and y coordinates? What are my x and y coordinates of the point C? It is, let's say, cos of the angle. So the angle has changed to pi by 4 plus theta, and sine of the angle, sine pi by 4 plus theta. Yeah? Yes, Ishwari.
So would the x value just be negative? So cos pi 4 by theta plus theta would just become...
Don't go anywhere. I would say hold it for a little bit. Okay? Alright. Now, we have just seen the movement and we just see what has changed. Now, what did we do? We just rotated this triangle by 90 degrees. We did not change the value, meaning whatever was this value from here to here is same as this value. So whatever was my x coordinate before has become my y coordinate if I am looking at this triangle. Make sense? And it would need little bit of visualization on your part as well when I'm talking about it. Okay. So look at this triangle. This was my triangle. I rotated by 90 degrees. It came here. Okay. So let me color this part. What is my this angle? The colored black angle. This is also theta, right? We just moved by 90 degrees. Yeah. Are you guys with me so far?
Yes, sir.
Okay, so now when you visualize this triangle AOB and triangle COD, what has changed here by rotating this? Whatever was my x-axis has become my y-axis. Whatever was my y-axis has become x-axis. Is that making sense?
Yes, sir.
Okay. Now, so whatever I said whatever was my x-axis value has become my y-axis value. That means what was my x-axis value? O to B. This was my x-coordinate, which was cos theta. Cos theta has become my y-coordinate here. So what is my y-coordinate? Sine pi by 4 plus theta. Or for the sake of simplicity, I will say 90 degree plus theta. Yeah. So whatever was my x value has become a y coordinate value here. Okay. So in this case, what was my x coordinate here? Cos theta, which has become a y coordinate here. And for in this case, what is the value of this y coordinate? Nothing but sine 90 degree plus theta. So what do you see here? Cos theta equals 90 degree plus theta. Now, same way, if you look at the y coordinate, what was the value for the y coordinate? Sine theta. This became the x coordinate here now. So that equals this, just the absolute value if you look at it. Okay. So if you just look at the absolute value, this length is equal to this length. And what is the value of this one? This is what is the x coordinate here? So cos 90 degree plus theta. Yeah. And now coming back to your point, Ishwari. So this value was positive here. and this value became negative. So this became minus cos of 90 degree plus theta. So what is the relationship you see here? Cos of theta equals sine 90 degree plus theta, and sine of theta equals minus cos of 90 degree plus theta. So in case of cos, if you look at the corresponding sine value, it is equal to 90 degree plus that value. In case of sine, it is equivalent to cos 90 degree plus that value, negative of that. Now you look at another correlation here. Now forget about whatever we have written here. Let it be. Now look at this triangle. This triangle. What is the? This is theta, and this is my x coordinate. This is my y coordinate. So here, in case of this guy, what is the, if I look at the sine theta value, sine of this theta, this equals this value, which is negative of whatever is the, or I will not even worry about that. I just know the x and y coordinate values, okay? And let me not worry about the negatives. Let's not worry about the negative, okay? Just look at, this is your value and this is your value. Whether it turns out to be positive or negative, we'll not care about it. We will let that come as a part of the calculation. So now here, this theta equals this value, this x coordinate value, which is cos 90 degree plus theta divided by the hypotenuse, which is y. And then if you look at the cos of this angle, so this will be this height or the y coordinate value divided by the hypotenuse. Y coordinate value is sine 90 degree plus theta divided by radius plus 1. So this is exactly what you see here. Sine theta equal to cos 90 degree plus theta, and cos theta equal to sine 90 degree plus theta. This is essentially what periodicity means. How do you find out the relationship when you add the angle, or when you add 90 degree to the angle? Meaning, if you have a cos theta and you add 90 degree to that, that will be equivalent to sine theta. If you have a sine theta, you add 90 degree to that, that becomes equivalent to cos theta. This is or you can relate that as pi by 4 or whatever it is. Okay. So this is essentially what is periodicity. In simple terms, when you have an angle theta, when you move by 90 degree, what changes? What changes is this. So whatever is the value of sine 90 degree plus theta, that will be equal to cos theta. Whatever is the value cos 90 degree plus theta, that will be equal to sine theta. That is essentially where you see that it's becoming a closed circle, right? If you add 90 degree to the sine theta, this becomes equal to cos theta. If you add 90 degree to cos theta, that becomes equal to sine theta. Now, if you look at this with respect to the complementary angle thing that we had learned, right? That said sine of theta equal to cos 90 degree minus theta, and cos of theta equal to sine 90 degree minus theta. So what we are doing is we are just correlating it to the next level. Or how you interpret that? It is when you are adding theta to 90 degree, adding 90 degree to the theta, okay. So basically, yeah. So the complement, it's just the continuation of the composite angle theorem that we have learned. That when you are adding or subtracting theta from 90 degree, it is equal to the opposite of sine or cos of that angle. Is that making sense, or is it complicating things? So, yeah, sorry, go ahead. You were saying something.
I was just gonna say it makes sense.
So now, what did we do so far? We looked at angle theta and then found out the x and y coordinate, and then rotated this theta or increased that angle theta or added 90 degree to it. It became 90 degree plus theta, and these were my new coordinates. From that we are able to derive the relationship that add 90 degree to whatever is your sine value, it becomes equal to cos theta. Add 90 degree to your cos value, it becomes sine theta. And we know from the complementary angle concepts that sine of theta is equal to cos 90 degree minus theta, cos of theta is sine 90 degree minus theta. So when you join these two concepts together, what you interpret is adding or subtracting theta from 90 degree gives you corresponding sine or cosine. That's the one line summary that we can derive from whatever we have done so far. Is that getting registered, or is it getting confusing? Arya, Dev, Rehan, Ishwari.
It makes sense, but I'm just thinking about it.
Okay. So see, the only thing that will come as an element of confusion is you will think that okay, this is negative side, so I have to take negative. Why do you even worry about it? Because your coordinates on the unit circle will remain this value, cos of the angle and sine of the angle. Whether that value is negative or positive, that you don't have to worry about. That's what unit circle theorem has taught us, right? Any point on the unit circle will give this value. Now we know that okay, when you're talking about 90 degree plus theta, that makes it 135, let's say it's 45 degrees. So this becomes 135 degree. It falls in the second quadrant. If it falls in the second quadrant, then my x value will be negative and y value will be positive. So from that you can relate it, okay? So you'll say, okay, fine. This equals this theta. Let's say if this theta is 45 degree, we are talking about this one. So this becomes cos 90 degree plus theta. Cos 90 degree plus 45 degree will be equal to cos 90 degree plus 45 degree will be equal to sine theta. Now this theta is 45 degree. So what is the value here? That is sine 45 degree 1 by root 2. Since this is falling in the second quadrant, it will be minus 1 by root 2. Yeah? So you have to do two things. One is knowing the unit circle theorem and how do you derive the coordinates, and then you relate that with which quadrant it's falling into. Okay? Or if you want to make it explicit, you can always say, okay, fine, sine of this theta equals 90 degree plus theta, this value, and this value is the x coordinate here. So this is negative here. Or if I'm talking about cos of theta is equal to sine 90 degree plus theta, 90 degree plus theta. So this value here, in this case, yeah. So this is 90 degree plus theta. 90 degree plus theta is this, and this is giving me cos of theta is the x coordinate. So let me relate it. So sine of theta is cos 90 degree plus theta. So if this angle, okay, so let's not make it confusing. This is what we derive from the relationship, and this is only giving you the absolute value. Okay, so this says okay, cos of theta equals this one, sine of theta equals this one. Now when you talk about a theta being 45 degree or 95 degree or whatever degree it is, then you just look at what my value would be, and then which quadrant it falls into, and then accordingly you can put a sign to it. Yes, Ishwari.
So I don't know if this is like the right question to ask,
Mhm.
but if instead of going counterclockwise, you were going clockwise, and the angle was negative, so theta was a negative value, could you still use the same equation?
You'll still use the same equation. So again, be it clockwise or be it anti-clockwise. If you are coming here, if you are going anti-clockwise, you are always saying measuring this angle as negative. When you travel in this direction, you are measuring this as positive. When you are going in this direction, you are measuring this as negative. So if you are coming here, this is your angle theta. So this becomes the let's say this is point E. Your x quadrant is cos of minus theta, and then your x quadrant becomes sine of minus theta.
So the sign would just change.
The sign will just change. Yeah, correct. So your attempt should be, when you are looking at a unit circle, you are visualizing two things. One thing is this is a circle with a radius as unit, and then your x and y coordinate value based on the angle, and then you have to relate that with which quadrant it is falling into. Yeah. Are you still thinking?
No, I got it, sir.
You got it? Okay. Dave, are you with me? Dave and Rehan?
I get it, sir.
Yeah, okay. So this is essentially about periodicity. So whenever you talk about periodicity, you're just talking about the relationship, how this changes by moving the angle by 90 degrees, be it for sine, be it for cosine, or be it for tangent. And your underlying concept remains the same. Everything revolves around the basic concept of your unit circle thing, which has taught us one thing, that any point on the circle, just look at how much angle that makes with the x-axis, and it will be cos of theta and sine of theta. This will be my x and y coordinate, regardless of how much is the angle. What this one teaches us is sine of theta. We had learned from the complementary angle concept that sine of theta is equal to cos of 90 degree minus theta, and cos of theta equals sine of 90 degree minus theta. And here from this periodicity thing, that what we have learned is sine of theta equals cos of 90 degree plus theta, and cos of theta equals sine of 90 degree plus theta. This is without considering the quadrant. Now when you know that, okay, when I'm talking about 90 degree plus theta, that means I'm going to the second quadrant. And if I'm going to the second quadrant, my y coordinates will remain positive. So whatever is the value of the y quadrant, here my y quadrant value will remain positive, and whatever is the value of my x quadrant, that will become negative. So if you are moving this way for 90 degrees, that means this becomes your theta, this angle. And if you look at this part, whatever is the value coming for x quadrant, which will be here this theta, sine theta basically. So sine theta here, which is this value, this part will be negative, and whatever is coming as your y quadrant, which is nothing but the cos theta, I mean just this angle, when I'm looking at this angle related, whatever is my y, this one, which has become this part, which is cos theta, this will be negative. So we know anyways that the sine, my screen gets locked. So we know that sine, when it goes beyond 90 degree, it goes in the negative direction. Whenever, because your sine is this one, when it goes into this quadrant, this becomes your the cos part and this becomes your sine part. So this will be negative, and whatever is your base, that becomes your, so whatever is your base here, that becomes your base or the y coordinate. So that whatever was your x before, that became y. So x was positive, y remains positive. Your y was, whatever was your y quadrant or y axis value or y coordinates, sorry, whatever was your y coordinate, that became your x coordinate, and that will be negative. So this is the absolute value, and then you have to just relate with which coordinate is falling into, and that will give you the value of that being positive or negative. Okay. Or you can just say that, or you can just say, okay, fine, this is my theta, this is 90 degree plus theta. So it went to this side. So what is my, so when you go to this side, this becomes your, this is 90 degree plus theta, and this is theta, right? So this is 90 degree plus theta, this is 90 degree, this is 90 degree minus theta. 90 degree minus theta plus, okay, yeah, correct. So this is theta. So if you look at this triangle here, you can relate it with this one. So that your y coordinate value is positive. So y, which will be sine, this will be sine of 90 degree minus theta. This will be positive, and sine of 90 degree minus theta is nothing but cos theta. So basically you'll have to just visualize this, okay? So what doesn't change is your the basic way to calculate how the relationship happens, and then depending on which quadrant it falls in the unit circle, you can decide, you'll be able to decide or determine whether it will be a positive value or negative value. You have to just look at which value of, so I'm probably complicating this by trying to simplify this. Let me do a fresh start, and then this is your unit circle, this is your theta. What doesn't change is theta, okay? So if you move this by 90 degree, so you came to this total angle is 90 degree plus theta. And if you look at this angle, this is 90 degree minus theta. That is how this angle plus this angle makes it 180 degrees. Now you can, from this one, what did we know? What did we find out? That sine 90 degree plus theta equals cos theta. Now look at sine 90 degree plus theta is cos theta. Now what is cos theta? If you look at this triangle here to here, cos theta will be sine 90 degree minus theta. That is by complementary angle formula. This is equal to cos theta, and that essentially equals to this y coordinate, right? So here, if you look at this triangle versus this triangle, from this one you are getting that your just 1 second. Let me just think through how we are relating it. Let's not complicate it. Let it remain here, okay? Let it remain here, because if I try simplifying it, I will eventually complicate it. Okay? Let me not do that. I will try finding out if there is a correlation that I can draw from this. But for now, same thing. I'm just doing a recap. Any point on the unit circle, the coordinates are cos theta and sin theta. And from the complementary angle formula, what we have learned is sin 90 degree minus theta equals cos theta, and cos 90 degree minus theta equals sin theta. And from this periodicity, what we saw was sine of 90 degree plus theta is equal to cos theta in absolute terms. Here these are absolute values. Cos of 90 degree plus theta will be equal to sin theta. This is what we have seen so far, and that is what we will stick with for now. And when it comes to deriving whether the value will be positive or negative, that will be a function of which quadrant it's falling into. Is that a good point to stick around, or that is not?
I think it's a good
Okay.
starting point.
Okay. How about you, Dave, Rehan, and Arya?
I agree with that.
Okay.
Yeah, I agree.
Yes, sir, I agree.
Okay. Now, so this is when you talk about periodicity, this is what it is. In summary, we talk about how the value of an angle, or how the value of sine, cos, and tan changes by changing the angle. Okay. What I will do is, after the class, I will send you guys just a quick recap of how do you derive conclusion from by changing this thing, right? Right now I have given the absolute value. I will just put a correlation here after the class, just as a reference point. Okay, so that way you have a table to refer to, and from that you can derive conclusion. Okay, so that way you will not be confused, or you will not have to worry about which quadrant it falls into, and then how do I calculate. Okay, I'll probably draw something like a table. Okay, and say if I have sine theta, cos theta, sine 90 degree plus theta, cos 90 degree plus theta, and cos sine 90 plus theta, sine 90 minus theta, cos 90 plus theta, cos 90 minus theta, and what will be the corresponding equivalent. I'll put that in a table so that becomes like a reference point for you, so that you don't really have to kind of keep struggling with how this changes. And then I will put that sine thing also, so that way you don't really have to struggle with figuring out which quadrant it falls into. Okay. Now you will say that, why do we have to do all this struggle, right? What is the point of doing it? So like we learned from the complementary angle thing, right, that if you have, let's say, if you know the value of sine 30 degree, this gives us a lot of information with respect to how I can derive some other values. So complementary angle theorem says sine of theta equal to cos of 90 degree minus theta. That means if I am talking about sine 30 degree, that will be equal to cos of 90 degree minus 30 degree, which equals cos of 60 degree. So whatever is the value for sine 30 degree, that is equal to cos of 60 degree. And then from that you can say, okay, fine, if I know sine 30 degree equals to 1 by 2, then cos of 60 degree I don't have to derive, it is 1 by 2. Or vice versa. If somebody says sine of 10 degree equals something, find out cos of 80 degree. And then you know that, okay, this is by a complementary angle, this is what it is. So in that case, same way here, if you are talking about the periodicity, we are essentially talking about, if I know sine of 30 degree equals some value, what will be that value when I am talking about sine of 120 degree versus cos of 60 degree versus cos of 120 degree. And I should be able to derive all this by relating to this. So this and this are same. Similarly, if I know sine of 30 degree equals cos of 90 degree plus 30 degree. So from this I should be able to derive the value of this also. Similarly, if I know the value of this, I should be able to go back to value of this as well. Yeah, so it actually it widens our ability to derive the value for different angles if you know one of it, and all that correlation helps you, without memorizing the value for different sine or cosine or tan, you should be able to derive it. So that's the main purpose of whatever we have learned with respect to the unit circle, or with respect to the periodicity, or with respect to complementary angle concepts around trigonometry. Is that making sense?
Yes, sir.
Now, same way, other thing. If you know, let's say you're talking about unit circle. If you know the sine of, let's say, 45 degrees, and if you have to find out, let's say, cos of 225 degrees, how will this whole understanding help? You know that 45, this is 45 degree. I can write cos of 225 degree equals cos of 180 degree plus 45 degrees. Right? Now, essentially, if you're talking about 225 degrees, you're talking about traveling up to here, which is 180 degree, and then 45 degrees here. So you're talking about this part. Now, if you know 45 degrees, you will simply ignore this part and you will come here and you will say this is my 45 degrees. So, if it is 45 degrees, how will you find out the value for cos for 225 degrees? So, here this is your theta, which is nothing but 45 degrees. And what happens in case of cos? This is your x coordinate and this is your y coordinate. Your x coordinate becomes negative. So from this one, sine 45 degrees, you know that okay, this is equal to cos of 45 degrees by the complementary angle concept, 90 degree minus 45 degrees, right? So cos sine 45 is equal to cos 45 degree. So this, if sine 45 is 1 by root 2, your cos 45 is also 1 by root 2. So you know that the value is your absolute value is 1 by root 2. Now, since we are talking about this, and this is my 45 degree angle, this is my x coordinate, and if I am talking about this angle's 45 degree, this is my length, which is 1 by root 2, and 1 by root 2 in negative direction. So cos 225 becomes minus of cos 45 degree, and that equals minus 1 by root 2. So basically, if you look at the concept, all these things that we are trying to learn here is just helping us or enabling us to derive the value of sine, cos and tan around this unit circle. I mean, I don't think I will ever have that ability to memorize value for 225 degrees. But if I know the theorem, how things relate, how do I plot this on a unit circle and derive which angle I am talking about, and then correlate that with the concept that we have learned to arrive at that. Does that make sense? No?
Yes, sir.
Yes.
Yeah. So this is on periodicity, this is on unit circle theorem, and we learn about the complementary angle concepts also that we had learned before. So we just did a recap and we tried that. So before I move on to the inverse of sine, cosine and tan. So again, whatever we talked about sine and cosine, tan is nothing but sine of theta by cos of theta. So this is what helps us get the value. So as long as we understand the sine and cos concepts, so if I'm talking about tan of 90 degree plus theta, then essentially I'm talking about sine of 90 degree plus theta divided by cos of 90 degree plus theta. So here you know that sine of 90 degree plus theta will be equal to cos of theta, and cos of 90 degree plus theta will be equal to sine of theta. Only thing that you have to remember is sine of 90 degree plus theta. Sine of 90 degree plus theta. So basically, when you are moving this by 90 degree, this part which was your for theta, that became your x coordinate, and positive became negative. So sine of 90 degree plus theta, this value whatever it is, that will be a negative value. So it becomes negative of cos theta divided by sine theta. Okay, and so just pay attention to what I'm saying. Okay, so here when I'm trying to find out sine of 10 of 90 degree plus theta, that will be equal to sine of 90 degrees plus theta by cos of 90 degree plus theta. This part is okay. Now what we have learned from the theorem of periodicity is absolute value is sine of 90 degree plus theta equals cos theta, and cos of 90 degree plus theta equals sine theta. This is the absolute value. Okay, we have not looked at the sine part yet. So sine 90 plus theta, I can say this is equal to cos of theta from this. So I put cos theta, and then cos 90 plus theta equals sine theta in absolute terms. Now when you look at this, when you rotated this by this 90 degree, so your whatever was your y coordinate, that became your x coordinate, and that is negative. So what was my y coordinate here? In this case, this value was sine theta. So sine theta became this value, which is negative, and this was your x coordinate, which became this, and that the value remained the same, but it was positive, this remained positive. So your cos theta by sine theta multiplied by a negative. Okay, so this became minus cos theta by, or you can say minus 1 divided by sine theta by cos theta. I am just converting this to this thing. So what happened was 10 90 degree plus theta equals 1 minus 1 divided by 10 theta. So from this, what you can see is, if you have a slope with a theta, if you rotate that by 90 degree, multiplication of this slope and this slope becomes minus 1. That is the corollary that you can draw from what we have seen just now. So this is 10 part of the periodicity. So basically what it says is, when you have a line, it has some slope, and you move that line by 90 degree, your new slope is minus 1. This slope multiplied by this slope will give you a minus 1. That is what you would have seen in algebra also. That how do you look at when you move the line by 90 degree, what happens, and what is the corresponding slope of the new line. So this is again just proving the same thing here. Were you guys able to follow me, or I was going with my understanding?
I have to follow, sir.
Yeah, Dave, Rehan, everybody.
Yes, sir.
So just okay. I mean inverse sine, inverse cosine, inverse tangent, which is also called arc sine, arc cos, and arc tan. We can probably cover that in the next class, but just wanted to emphasize this thing, that this is exactly what we learn when we talk about the periodicity. When we rotate the angle by 90 degree, this is what happens in terms of absolute value, and then you relate that with the unit circle, look at the coordinates, and based on that you kind of and why I was focusing on the absolute value, because that helps you kind of relate, that you get the absolute value, and then you can always say, okay, fine, this was my value, this was my y coordinate became my x coordinate by rotating this. So whatever was the value for y coordinate, that value remains the same, but here it was positive in this first quadrant, when it went to second quadrant, it became negative. So you can see, okay, fine, this was my value, the absolute value remained the same, but in terms of sine or cosine, whatever it converts to, that will be negative. So that is how, when we saw the sine 90 degree plus theta, sine 90 plus theta equals to cos theta. Same value, but then since this is moving to this side, it becomes a negative. Similarly, cos 90 plus theta in absolute value terms, it will be sine theta, that's what we derived. And what is cos 90 plus theta? Sorry, cos 90 plus theta equals to sine theta. So sine theta is okay. Sine 90 plus theta equal to cos theta. Yeah. Alright. Yeah. So sine 90 plus, what am I saying? So whatever was my sine 90 plus theta will be equal to cos theta. Cos theta is this value, this went this side, that remained positive. When I'm talking about cos 90 plus theta, so here this equals sine theta, so whatever was my value for sine theta, that became negative. So that's how you relate. So this gives you absolute value, and sine 90 plus theta, if you're talking about sine 90 plus theta, you know that you're talking about which value, which is your y coordinate. So when this moved here, what became your this y coordinate, and then you look at the corresponding which quadrant it's falling into, and map it with the corresponding value. Does that make sense? So now this is what I would request you guys, okay? So whatever we have done, we have kind of juggled with a lot of things, okay? And I was kind of forcing you guys to visualize a lot of things, and that might have created confusion. So I'm not saying that I taught these concepts in the cleanest possible way. I might have gotten you guys a little confused. So my request would be, take a piece of paper and do the same thing like all the dirty work that I was doing on the board. Draw a circle, look at theta, rotate by 90 degree, look at this theta, what is the sine value here, what is the sine value by rotating this one, and then look at the coordinates, look at the possibility of positive or negative sign. Second quadrant, your y value is positive, x value is negative, what is your x value and what is your y value, and then kind of try deriving some conclusion out of it. I will also send you guys the table that I was talking about, so that will also help you reascertain that, okay, this is how you relate it and use it. That makes sense?
Yes, sir.
So a little bit of homework, but this is more around the concept. So I might understand the concepts in my own way, but then when you guys do that scratch work and kind of do it one more time, you might find a better solution or better approach to memorize this or relate it. Teach all of us, okay? Because sometimes students can do a better job than the teacher. Yeah. And then we looked at the tangent part of periodicity as well, where we rotate the angle by 90 degree, and from that we found that tan of 90 degree plus theta equals tan theta, but then it is the inverse negative. So tan of 90 degree plus theta was equal to minus 1 by tan theta, meaning when you multiply the slope of two perpendicular lines, you get a minus 1. Tan theta is nothing but the slope, right? For any angle, when you talk about this tan theta, you are essentially talking about the slope or or basically the correlation between how y increases for every increase of x, right? So that's why tan theta is y divided by x. This by this, right? So it essentially says your slope is low or high depending on how quickly y changes for every change of x. So tan theta is that. So basically you are talking about tan theta of this line versus tan theta of the line perpendicular to this. Multiplication of this slope into this slope gives you a -1. So this is something that you will see in, when we go back to algebra concepts also, and you'll be able to see the correlation that we have seen here versus what you'll see in algebra as well. Make sense? Yeah?
Yes, sir.
Okay. Now, quickly touching upon the inverse. So look at it this way, okay? Be it arc sine of any value, it can be denoted also as inverse of sine of the same value, and that will result into the angle that we're talking about. Similarly, arc of cos, let's say 1/2, will be same as inverse of cos 1/2 will be equal to 60 degree. Now here whatever I'm doing on the board, it essentially relates to the same concept, which is looking at sine, cos and tan with a inverted glass. Or we know that sine of, let's say, 30 degree equals 1/2. So when you talk about inverse sine, or it's also called as arc sine, then you say, okay, fine, this of 1/2, basically you move this angle to this side and get this value this side, and this sine changes, equals 30 degree. So arc sine is always like inverse of sine for a given value will be equal to what angle. Arc of cos or inverse of cos will actually give you the angle. So let's say if you come across a point which says tan of 1, meaning it is actually asking you, or arc 10, it is essentially saying that tell me for what angle of tan theta my value will be 1. Okay? What angle of tan theta my value will be 1. That is how you will read it. So that is all about the inverse function. So if we have understood the concepts of how do we use unit circle, how do we find the angle, how do we use the basic suka to a concept to get the value for different angles, this is just an inverse of that. That's why it's called inverse of sine, cos and tan. It is just a different way of looking at it. So the questions that you will get is, okay, tan of 40, let's say 90 degree equals infinity. So what will be the inverse of infinity? So basically you have been asked to find out the angle for which tan theta value will be infinity. So that's essentially all about the inverse function. What I would suggest you guys is go to Khan Academy, go to pre-calculus topic, go to unit 2 and this particular section, I think it's chapter 3 or chapter 4, and then try doing the unit test where you will have certain questions and try relating these concepts to solve those. And once you try solving it, then you will know whether your teacher has actually taught you the concepts right, or we still have some elements of confusion that you would want to get clarified in the coming class. Will that be the okay approach?
Yes, sir.
Yeah. So again, sometimes I don't feel confident of what I teach, right? And that becomes an opportunity for me to teach things in a easier, simpler way. So whatever we have done today, let me put that table across and then let you guys do some test, some unit test by yourself, and then come back to me saying, okay, sir, I don't think we understood this. And it's perfectly fine. I mean, that gives a second chance, right? Not everything that we learn it right in the first go. If we have an opportunity, we'll come back to that. If that requires me to brush up my own concepts one more time, I'll do that for you guys. Okay? So that's what the plan would be, let's do some test after I send you that table, and let me know how confident you feel with whatever we have learned, and if we have opportunities, we'll come back to it. Yeah?
Yes.
Arya, Dev, Rehan, is that okay?
Yes, sir, that's fine.
Okay. Alright. Alright, so I'll let you guys go, have some rest, and see you guys on next Wednesday. But make sure that if I'm not sending you that table, remind me. Don't even hesitate to let the teacher sleep. Okay?
Okay, thank you, sir.
Alright, bye-bye. Take care. Bye, Dev. Yeah.
I have a question.
Okay.
So I'm taking pre-calc right now, and in school